Let's look at some identities of our trig functions. First of which we'll look at is the reciprocal identities. Let's start with the cotangent of the angle. We've actually seen this before with a few other examples, but cotangent is basically the reciprocal of tangent. So this is 1 over the tangent of theta. We also saw that the secant of theta is 1 over the cosine of theta. And then the cosecant of theta is 1 over the sine of theta. Now this can work the other way as well. If cotangent is the reciprocal of tangent, then tangent is the reciprocal of cotangent. So I could also add on 3 more identities here. So tangent of theta is 1 over the cotangent of theta. Cosine of theta is the reciprocal of secant of theta. And then sine of theta is the reciprocal of the cosecant of theta. Okay, so those are our reciprocals. Let's see the next one called the quotient identities. We start with the tangent of theta. Now within a right triangle, we've defined this as the opposite over the adjacent. What I'm going to do is divide the top and bottom by hypotenuse. So we would have the opposite over hypotenuse over the adjacent over hypotenuse. Okay, so this is equivalent because I'm dividing top and bottom by the same thing. Now, opposite over hypotenuse within a right triangle we define as the sine of an angle. And adjacent over hypotenuse was cosine of the angle. So this is actually a quotient identity for tangent. So tangent of theta is the sine of theta over the cosine of theta. We could do the same thing for cotangent of theta. Or again, just understand that cotangent is the reciprocal of tangent. So just flip that over. Okay, so using these identities, I'm going to give you 4 trig functions of theta, and I'm going to give you 2, and we're going to find 4 remaining trig functions of theta. For example, let's say you're given that the sine of theta is 4/5, and the cosine of theta is 3/5. So anytime you're given a trig function, you immediately know it's reciprocal. So using our reciprocal identities, let's abbreviate that RI, we immediately know the cosecant of theta as being the reciprocal of sine, so 5/4. And we also know that the secant of theta will be the reciprocal of cosine, which is 5/3. Okay, so we've exhausted the reciprocal identities, so let's go with the quotient identities. Since I'm given sine and cosine, then I immediately know tangent of theta as sine divided by cosine. Okay, so again, tangent of theta is sine over cosine, so 4/5 over 3/5. And since we divided top and bottom by the same thing, those 5 would just cancel out, giving us 4/3. Then I'll just go back to a reciprocal identity, because now that I know tangent, I know cotangent. So 3/4. Let's look at one more like that. Again, I'll give you 2 trig functions. We're going to find the other 4. Let's say that the sine of theta is 2 squared of 2/3. And the cosine of theta is 1/3. So again, once you are given a trig function, you immediately know it's reciprocal. So I know that the cosecant of theta, these are reciprocal identities, would be 3/2 squared of 2. Rationalizing top and bottom by square root of 2. So we get 3 squared root of 2 over 2 times what will now be 2, so 4. Okay, I also know the secant of theta being the reciprocal of cosine, so that's 3. Okay, so I've exhausted my reciprocal identities, so let's move on to the quotient identities. So since I know sine and cosine, I know tangent, which is defined as sine over the cosine. So again, I'm dividing top and bottom by the same thing, so those just cancel out, leaving me with 2 square root of 2. So then the cotangent can be found by using the reciprocal identity, because that's the reciprocal of tangent. So 1 over the 2 square root of 2, rationalizing. So the bottom becomes 2 times 2, which is 4.